Now we will see some of the important model questions based on reflection of light. Okay. So, mainly in our reflection of light phenomenon, we are having total two cases we have. One is about the plane mirror, another one is about spherical mirror. Whereas, in case of plane mirror, most of the questions coming from the angles with their relations we have. In most of the cases, plane mirror questions based on the distances or the relation between the angles we have. And if you see the plane mirror questions about the angles, we already know about the relation between the angles. So, that here angle of incidence and angle of reflection both are equal, and along with that we are having glancing angles are there, whereas those glancing angle of incidence is equal to glancing angle of reflection, and we have angle of deviation is there, which is of equal to 180 minus 2i we have, where I is the angle of incidence again. And also we have that angle of deviation is also equal to glancing angle of incidence, that is, which is of twice the glancing angle of incidence we have. That is about angle of deviation. These are the relations between the angles we have in different cases when you are using a plane mirror reflection, that is. For example, for the questions you will get like this. If you are considering any of the plane mirror, let us suppose a ray of light incident on that and it is reflecting back. So, that here the angle given is about theta is equal to, let us suppose 20 degrees is given. Then what you have to find is here what is this angle theta, this is how much, this is the question given. Okay. For examples, options are like this: option A given 20 degrees, option B 40, and option C, let us suppose it is of 120 degrees, and option D, let it be that is 60 degrees, like this. Okay. Now, here if you observe this angle of glancing, that is actually this is our incident ray, and here this incident ray is making some angle with the mirror, and we know that this here we are having a normal is there at here. Now, if you are taking the normal, this is called as angle of incidence I. Okay, and this becomes 20 degrees is given there. Now, we know that if you are taking the normal it is about perpendicular line, that is, which is about 90 degrees we have. As it is about 90 degrees is present, in that 90 degrees this is already given angle is 20 degrees, that is. Then the other angle becomes, as it is of I is equal to, in this case 90 degrees is total, in that already we have 20 degrees is there. Then angle of incidence becomes 90 minus 20, which is 70 degrees, that is. So, we got our angle of incidence is 70 degrees. By using that first formula I is equal to R here, then we can get this angle which is equal to angle of reflection, that is. As angle of incidence is equal to angle of reflection, then we got it is equal to 70 degrees, that is. As the angle of reflection it is about 70 degrees, then again the normal makes an angle with the surface of 90 degrees there, and angle of refraction is given 70 degrees, that is. Then the remaining angle becomes this theta is equal to that 90 degrees minus 70 degrees, that is, which is equal to 20 degrees. Actually, this angle we call that as a glancing angle of incidence, this angle theta we call that as a glancing angle of reflection, that is, which means taken from the second one, that glancing angle of incidence is equal to glancing angle of reflection, that is. So, that is why here the final answer becomes A, that is, which is angle of reflection, that is of glancing angle of reflection theta is equal to 20 degrees, that is. Like this, depending on the given one, by using those formulas of I is equal to R, we can find the angle. For example, if it is the same problem, if you want to find the angle of deviation here, okay, in the given problem, which is of we are taking the 20 degrees angle there, which is making with the surface, then what we need is we have to find angle of deviation. Angle of deviation is how much? Then we know that if it is of angle of deviation, then angle of deviation formula is angle of deviation is equal to 180 minus 2i, that is. Then as it is of 180 minus 2i, then 180 minus 2 into angle of incidence it is of 20 degrees is there, sorry, glancing angle of incidence is 20, then angle of incidence we got 70 degrees, that is. Then it is 180 minus 2 into 70, which is 140, then 180 minus 40, which is of 40 degrees, that is. That is our angle of deviation. Okay. Actually, this angle of deviation we can also find from another formula, which is angle of deviation is twice the glancing angle here, of which twice that of glancing angle already given, that is of 20 degrees is there. Then 20 into 2 into 20, it becomes 40 degrees, that is. Like this, depending on the relation they are asking, we are having different answers are there for this. We can find the angle of deviation, we can find the glancing angle there. Even sometimes they will ask to find what is the angle between the incident ray and the reflected ray also. If you are finding for the angle between the incident ray and the reflected ray, which means this angle you have to find. As glancing angle is given 20, angle of incidence is given as 70 degrees we are getting, and angle of reflection also 70 degrees. Then angle between the incident ray and the reflected ray becomes, that is of 70 plus 70, it becomes 140 degrees, that is. Okay. Like that, we can get different relations between the angles if you are using in case of this plane mirror, that is. We will see one more question based on relation between the angles. See here, a given figure we have having two plane mirrors are there this time. This is mirror M1 and this is mirror M2, that is. When a ray of light strikes the mirror M1, actually it reflects back onto the second mirror there. If you observe, here it reflects here to the second mirror. But here if you observe, that second mirror case, after reflection again it is over. Now the light ray is retraced back in the same path here, like this. Okay. Then the question is how to arrange these two mirrors, what is the angle between them, means the question is from the figure find theta there. Okay. We have to find the angle theta, that is. Then how to find the theta angle is actually here, whenever the light ray strikes the mirror with an angle 60 degrees there, if you are taking the first part here, okay, of which the light ray strikes here with an angle 60 degrees. This is with mirror M1 we are taking. Then after reflection is over, here we are having a normal will come, and here the angle is nothing but called angle of incidence for the first mirror, that is. This is our angle of incidence for the first mirror. Then that angle of incidence becomes, which is of, as it is the normal 90 degrees, and in this 90 degrees we are having that 60 degrees is present. So, that is why 90 minus 60 it becomes, which is equal to 30 degrees, that is. So, this angle of incidence part we got that as 30 degrees, the other side also it becomes angle of reflection, which is also again 30 degrees, that is. Then glancing angle of reflection other side, this becomes from this 60 degrees, that is, because this is again the normal. With the normal here it makes an angle 90 degrees, and this part we got 30 degrees, then the remaining angle becomes 60 degrees, that is. So, which means for the second reflected ray, which is of after reflection is over, now this angle becomes 60 degrees. That angle is becoming 60 degrees, that is. As that angle is becoming 60 degrees here, and the light ray is retracing back in the same path, here this angle becomes here nothing but equal to 90 degrees, because if then the light ray will reflect back into the same path, retracing back in the same path is, if you are taking, this is the mirror, if the light ray strikes normal there along the normal, then only the light ray is retracing back in the same path here. Using that condition here, for our mirror M2, the light ray is after striking the second mirror, it is striking moving back in the same path here, which means the angle made by that with the surface means that incident ray is coming along the normal for our second plane mirror here. So, that is why the angle between the second plane mirror and this incident ray becomes 90 degrees. But if you observe here, we are getting a triangle is coming. Let us suppose this is O, A and B. Now, here we are having a triangle is there, which is of OAB is present. Now, from this triangle OAB, of which from this triangle OAB, then we can get that sum of the angles inside the triangle, which is of 90 degrees plus 60 degrees plus theta is equal to 180 degrees, that is 90 and 60, which is of 150 degrees plus theta is equal to 180 degrees, then theta becomes 180 minus 150, which is 30 degrees, that is. So, the angle it becomes 30 degrees, which is the two plane mirrors are arranged at 30 degrees. So, that the second reflected light ray is now retracing back in the same path. Like this, we can find with the two mirrors also, we can find like this the angle relation between the angles here. Next one, given here are 4 figures are given, so that in all the 4 cases we are having a multiple reflection takes place. The light ray incident on one of the plane mirror and it is reflecting back to the other mirrors here. And here directly the relations also given there between M1 and M2. We are having all cases the angle between the two mirrors is 40 degrees, 40 degrees, 40 degrees, 40 degrees. Now, the question is of the given diagrams which relation is correct, that you have to find here. Okay. So, of the given 4 here A, B, C and D, of the given 4 which one is the correct relation we have to find. If you see the first figure here, of which we are having 40 degrees is the glancing angle of incidence and here angle between the mirrors is of 40 here. Then if you are taking for the case of first one, then in this case as the glancing angle it is of 50 degrees is given, then whenever it reflects back here, now that case is here the angle glancing angle also becomes 50 degrees, that is. As this is 50 degrees, this also becomes 50 degrees and it is given this is equal to 40 degrees, that is. Then here we are having a triangle is there, so that here it is given this is a 90, that is. Then this angle is as it is of it is forming a triangle here 50, 40 and let us suppose this is some x, then x plus 40 plus 50 if you take, that is equal to 180 degrees. Then this is a 40 plus 50 which is 90 is equal to 180, then x becomes 90 degrees, that is. X becomes 90 degrees, that is. Then if it is x is becoming a 90 degrees here, then which means this angle is a 90 we are taking now. Then if it is 90 degrees, this is the angle of incidence and it is given that is 90 degrees means the light ray is retracing back in the same path, that is. So, this going to be like a normal, to the normal both the other side we are having an angle 90 degrees is present. So, of the given equations our first equation is correct, because the other side also we are having same 90 degrees is present. Like this we can find different angles and their relations, that is. Now, we will see another question here based on reflection on the plane mirror. In case of normal incidence, the angle of reflection is, okay. See, normal incidence means the light ray is passing along the normal. For example, if this is the plane mirror, now the light ray is incident on the mirror perpendicular to the surface. This is called as normal incidence. Then if you are taking in case of normal incidence, the light ray actually retrace back in the same path here. So, means going back in the same path. Now, the question is in case of this normal incidence, the angle of reflection is they are asking. Then angle of reflection means it is nothing but the angle between the incident ray and the incident ray, that is nothing but the angle between the normal and the reflected ray, that is. As the reflected ray it is retracing back in the same path along the normal, then the angle between them becomes 0, because that is going to be our normal and that is going to be our reflected ray also. So, that is why the angle between them is becoming 0, which is case 1, that is, which is equal to 0 degrees, that is. But the same question if they want, they can ask like this. In case of this normal incidence, let us suppose you have to find what is the sum of angle of incidence and angle of reflection also they can ask. Sum of angle of incidence and angle of reflection also they ask. If they want to ask the sum of angle of incidence and angle of reflection during normal incidence, even that case also here, as this is the incident ray and this is the normal and incident ray both are merging here. So, that is why angle of incidence is becoming 0 and angle of reflection also becoming 0. Then angle between incident ray and reflected ray we want, but here if you observe the incident ray is coming downwards and the reflected ray is going up. So, that again the angle between them is becoming 0 only. Again we are giving the same angle between them becomes 0. Now, the same question if they want they can ask what about angle of deviation. When come to the case of angle of deviation here, angle of deviation is, it is about 180 minus 2I we have. Then it is of 180 minus 2 into, as angle of incidence is 0 here, 2 into 0, that is equal to 180 degrees. 180 degrees means as the light ray it is coming down here, which is incident on the plane mirror, it retraces back in the same path upwards. So that what happens there is, the angle between the extended incident ray to the reflected ray, it becomes 180 degrees. As the light ray is reversing back in the same path, that is why the angle of deviation is becoming 180 degrees. Or even in case of this normal incidence, if you take for the case of glancing angle this time, in case of glancing angle, we know that glancing angle is equal to, which is 90 minus angle of incidence, that is, which is of 90 minus 0, it becomes 90. So, of these cases, during whenever if the light ray strikes the mirror normally or normal incidence, then what happens there is, the glancing angles are maximum, glancing angle is maximum, and angle of incidence and angle of reflection is becoming 0, and angle of deviation is also becoming maximum, which is equal to, we got 180 degrees, that is. Okay. Like this, in case of this normal incidence, glancing angles are maximum, incident angle and reflected angles are becoming 0, and whereas angle of deviation is again becoming maximum we have. Now, we will see another question. Given that a person looks into a mirror by placing it closer to his face, and the image of his face is erect and same size than the mirror used is. Obviously, we know that as here it is given that particularly mentioned, that is of same size is given, then the same size images are formed by the plane mirror or a concave mirror here. So, means plane mirror or concave mirror. But actually the problem is here, the given that one option is about erect image. Erect images are actually formed by only the virtual images. Okay. See, means all virtual are erect, that is, all virtual are erect. Then in case of concave mirror maximum almost most of the cases it is forming real images only, but it forms only one case, that is of a virtual mirror, virtual image, that is, that too in case of a special case of which there we are getting a virtual erect, but a magnified image we are getting there. But in this case it is given that it is erect and same size is given. So, that is why both erect and same size it is given only by the plane mirror here, because the plane mirror characteristics are we are having, it is forming a virtual image, erect image, and it is of same size and at the same distance. As in the given options we are having plane mirror, concave, convex, or D given there concave or a plane mirror, we cannot take the concave mirror, because concave mirror forms the erect image only in one case, that too it is forming a magnified image. So, that is why plane mirror is correct in this case. But if the same question, if they are asking that is of the image of his face is erect and given that is of real and same size, if they give, for example, in place of this erect, they give that as a real and same size if they give. Once if it is given that is of real and same size, then obviously we know that plane mirror cannot form a real and same size image there. Okay. So, that is why in that case now the option will change and we can use convex or concave is the other option we have. Whereas, we know that convex case image characteristics we see, image characteristics of convex mirror is it always forms a virtual, erect and diminished images it is forming there, which is a convex mirror. Whereas, concave mirror it can form different types of images, that is, it can form a magnified image, it can form a diminished image, it can form a same size image, and not only that it always forms a real image other than the special case here. As in the given options we are having the same size and it is formed is a real image is there. So, that is why here the option becomes in this case concave mirror it becomes instead of plane mirror, because plane mirror cannot form a real image there. Plane mirror always forms erect and virtual image, but here it is given that is a real image is formed. Real image is formed by a concave mirror here. For suppose if the same question if they give like this, instead of given real image there, it is given that it is forming instead of real given that is of inverted, that is. Then all real images are inverted images, that you already know. As all real are inverted images, an inverted image with the same size, that is also again formed by our concave mirror only, because concave mirror only forms the real images here. When consider to the case of plane mirrors and convex, they always forms virtual and erect images, that is. Okay. Or the same question they may ask like this also, okay, which is erect image, but instead of getting the same size, it is given that is forming a diminished image. When come to the case of diminished image, concave mirror can form diminished images, convex also can form diminished images there. But here given options case there, we are having an erect and diminish is there. As it is given that is clearly mentioned erect and diminish, erect means nothing but virtual, that is. Erect means nothing but virtual, as it is of virtual and diminish. But in case of this, whenever if the concave mirror forms a diminished image, that is always a real image only, it can form as a diminished one. And we know that all real are inverted, but here it is given that is erect, which means we cannot take concave mirror, we have to take that is of a convex mirror, that is, because convex mirror is having the image characteristics of virtual and erect, and always it forms the diminished size images. Okay. For example, if the same question, instead of asking, if they give, in case of this diminished, they said that is of bigger in size, which is of magnified is given. If it is magnified image, then given options are what? If it is erect and same size, then we are having plane mirror we are getting. If it is erect and diminished, that is called as convex, that is now given erect and magnified, erect as well as magnified. Erect images actually they can form by plane mirror, they can form, concave mirror can form, convex mirror also form, because all the three cases we are having virtual images possibility is there. Plane mirror always it forms a virtual and erect image, but the problem is it forms only the same size images, that is. Whereas in case of convex mirror you take, even that case also we are having a virtual image and erect image only forming, but the size it is of diminution size we have. So that is why here concave mirror, of which we are having a special case is there, which is object is placed in between pole and the focus. There we are having a virtual image is coming, which is erect. Not only that, we are getting a magnified image is formed. So that is why if it is given erect and magnified is image given, then we can take that as a concave mirror, that is. Okay. So like this, depending on the reflection here the mirror, okay, from the same question we can ask in a different way. That is of first one we have seen erect and same size, this is one possibility. Next one inverted and same size, that is another possibility we have. Third one, which is of erect and diminish, that is another case possible. And after that we are having erect but magnified we have. Erect and magnified. Like these four possibilities we have, erect and same size, we know that that is a plane mirror case, and inverted and same size, that is about concave case, and erect and diminished case, which is of convex case, that is. And if you are taking erect and magnified, if you are taking, then it comes again concave. So which means the same question of taking about the size or the characteristics of the image formed there, we can take any of the possibilities there, erect with the same size and inverted with same size, erect with diminished or erect with magnified image. Next questions actually based on magnification you will get, okay, about magnification. Then if any of the question, if it is about magnification, which means about the size of the image and the size of the object we have to take. So that is given by a factor called magnification factor we have, which is m, that is. Okay. For this m we are having total two signs out there, which is m may be positive, m may be negative, that is. Okay. M positive when we will have is if you are taking a virtual and erect image, which means object we are taking above principal axis, the image formed is also above principal axis, then we are having positive is coming, which is virtual and erect cases. Okay. Then minus 1 we will get is if you are taking a real image and inverted image if you are taking, then in those cases also we are having same minus negative values we are getting that minus 1, minus 2 like that. Okay. And for these m values we are having 3 different cases we have, of which m value may be less than 1, m value more than 1 and m value greater than 1 we have. Okay. When you are taking the case of m value less than 1, then m value less than 1 represents that is a diminished image that is. And if m equal to 1, which means that that is of same size that is, and when m is greater than 1, then it is called as enlarged or magnified image that is. So, based on this m value which is of a plus and along with that different values of magnification there less than 1, equal to 1 and greater than 1. Okay. Different mirrors can give you different types of magnifications that is. For example, in the question they give like this, by using a mirror, when you are seeing through that mirror, you got a magnified image, so that the magnified image m is equal to plus 1 is given like this. If m is equal to plus 1, then what are the possibilities? A, B, C, D again, okay, of which we can take a plane mirror and we are taking a concave mirror and we can take a convex mirror, or like previous case we are taking concave or plane mirror we are taking. Now, here if m is equal to plus 1, what do you mean by that is, here plus represents that is a virtual and erect case, whereas 1 represents that is equal of same size that is, as it is given plus 1 and erect image or a virtual image is formed with a magnification equal to the same size of the object is given. So, which means erect and same size, that is given by only one possibility we have, that is of a plane mirror only it is forming. So, that is why if you are taking m equal to plus 1, that represents about plane mirror here, that represents about plane mirror here. But whereas in case of if the same question if they give m is equal to minus 1, if they give m is equal to minus 1, that is. If m is equal to minus 1 case, where that minus represents the image formed there is a real and inverted image that is. Then if it is of m is less than 1, that is which is of here same size, 1 represents the same size here and minus represents that is an inverted image that is. As it is forming real and inverted image with the same size, the answer is going to be concave here. Okay. For suppose if they give m value less than 1 plus 1 they give, for example like this, okay, which is of m is equal to plus half, m is equal to plus half if they give plus half, which is the value is less than 1 we have. Once the value is less than 1, then it is of given that is of diminished image that is. And not only that, the given sign convention it is of a plus is given, plus it is meant for only virtual and erect case, virtual, erect and diminished, that is formed by only convex mirrors that is. Like this, depending on the m values, we are having different possibilities of uses of mirrors are there. Then if you see all the cases there, then if whenever if you are taking m is equal to minus 1 case, then this possibility minus represents that is of real and inverted that is, and we are having 1 represents with the same size, the size is same. Okay. Then if m value is equal to plus 1 if you are taking, then we are getting plus represents virtual and erect and it is of same size that is, and 1 represents that is of same size that is. Then if you are having a value m value is less than 1, which is of plus 1 we got, then it is about m value less than 1 that is, okay, and that it is positive we are taking. Positive means that is about virtual and erect, and not only that, the size it is of diminution size that is, the size is diminution size, m value less than 1 and it is of positive we are taking. Okay. Then suppose if you are having m value less than 1 only, but we are having negative values are coming there. Example, m is equal to minus 1 by 2 like this. Okay. So, m actually it is less than 1 which is half, but the sign given is negative for that like this. Or some cases we have m value which is greater than 1 only, but here we are taking that it is of having values like this, m is equal to with negative values we are getting minus 2, minus 3 like this. Okay. So, these are the different possibilities we have for the case of m values, that is when you are taking m value is minus 1, that is if m value is equal to minus 1, then it is of real and inverted and it is of same size we have. And whenever if m is equal to plus 1 is there, we are having virtual and erect and is of same size we have. M is less than 1, but here we are having virtual and erect, that is, which means m values are like this plus 1 by 2 like this we have. And next case m value which is less than 1, but again we are having negative values are present, which means m equal to minus 1 by 2 like that, 1 by 3, 1 by 4 like that, but with minus. And here m value greater than 1, but we are having minus values are there and we are having possibility sometimes positive values also present, m is equal to plus 2 or m equal to plus 3 like that. In these cases, then how to judge that is, when you are given m is equal to minus 1, as I said, minus represents about the inversion here and 1 represents the size. Here real inverted same size, this is meant only for concave. And when you are taking m is equal to plus 1, which is about virtual erect same size, that is given by only plane mirror here. And whereas m value less than 1, which is of just like 0.5, but given it is a positive 1 we have, which means that is a diminished and not only that virtual and erect, that is, then that case that is of it is a convex mirror, that is of convex, that is. And whereas if you are taking m value is less than 1, which is a diminished and given that is of minus is there, diminished and it is of real, that is. Real and diminished, it means that it is going to be a concave mirror, that is. And not only that, if you are taking m value greater than 1, which is 2 there, 3 there like that, but with minus if you are taking, which means real inverted and enlarged, that is formed by only concave only, that is. And not only that, if you are taking a magnified image 2 and 3 magnifications, but with positive means virtual or erect, that is also possible only by using concave mirror, that is. So, depending on the m value given there, depending on the sign and depending on the number, its value less than 1 or greater than 1, we can judge which mirror we are going to use. Okay. Like this, we can arrange different types of competitive questions are coming from this magnification part. So, when it comes to the case of spherical mirrors, if you take of which spherical mirror formula is 1 by f is equal to 1 by v plus 1 by u. Okay. As if it is of 1 by f is equal to 1 by v plus 1 by u here, if you are taking for the case of a concave mirror, in case of concave mirror, then according to this in case of concave mirror here, whenever the object is coming closer, then gradually the image distance gradually increases, which means the u value and v value, they are related like inversely proportional to each other. Whenever if you are increasing the object distance, actually we saw that in the ray diagrams also, when the object is at a far distance, then if you are taking the image distance here, of which we got if object is at infinite, then image we are getting that at f value are getting, which is of a focus, that is object at infinite, image is at principal focus, that is. Okay. And we know that after that between beyond c or in between infinite and c, if you take, that is coming in between f and c, that is. Okay. Means whenever the object is coming closer towards the concave mirror, the image is moving away from that. So, which means how the u value and v values are varying, that is what important here. Okay. So, whenever the object is coming closer, always the image is moving away, or the object is moving away from the mirror, the image is getting now closer and closer towards the mirror we have. So, based on that, which is of the ray diagrams, we are having number of questions are asking there, that we will see in case of a concave mirror and convex mirror separate we will see. Now, we will see how it is related with the magnification first. Okay. Of which we know that as 1 by f is equal to 1 by v plus 1 by u, and we know that magnification m is equal to, if it is a concave mirror, we are getting inverted images. So, that is why we got that as a minus, that is minus v by u, that is. Then from this, as 1 by f equal to 1 by v plus 1 by u here, then 1 by f is equal to, we can write this as, if you multiply with v here or taking v common there, then take 1 by v common here, then we will get 1 plus 1 by v, if you take common here, you will get 1 by v plus 1 by v u, that is v by u, that is like this. Okay. Then if you multiply that inside, again we are getting the same. Okay. If you take 1 by v common, then if you bring that v this side, then v by f is equal to 1 plus v by u, that is. Okay. Then from this we can write 1 by v by f is equal to 1 plus v by u, that is nothing but equal to minus m, that is. Okay. So, 1 minus m is equal to v by f, that is. So, from this we can write f is equal to v by 1 minus m. Means once if you know the image distance, directly we can find the focal length here, f is equal to v by 1 minus m, that is. And in the same way, if you want, we can write even for the case of u also, which is, if you are taking for the case of u as 1 by f is equal to 1 by v plus 1 by u, then this time take u common, then 1 by f equal to 1 by u of 1 by u by v plus 1 it becomes, if you take 1 by u common. Then if you bring that u this side, again u by f is equal to u by v plus 1, then that is of here u by v, you can take that as 1 by f is equal to u by v, v by u is m, then u by v becomes 1 by m, that is. So, minus 1 by m plus 1, that is. Then if you bring that 1 by m this side, there you can write that as 1 by u by f is equal to 1 minus 1 by m. Okay. Then we can write from this 1 by m is equal to, from this f is equal to, if you cross multiply that u by u into 1 minus 1 by m, that is. Okay. If you cross multiply that, then you will get f of u into 1 u there, and f by, that is f is equal to u by 1 minus 1 by m, you will get like this. This is for the case of if object distance, image distance and magnification is given, and this is in case of if focal length and object distance and magnification is given. Or if you want to simplify that, you can simplify that here like this, f is equal to m u by m minus 1, that is m u by m minus 1, that is like this. Okay. So, by using that magnification factor also, we can find the focal length of the given mirror, okay, whether it is of object distance or in case of image distance, both cases separately we can find that. So, finally, we got the relation f is equal to image distance by 1 minus m we got. From this, actually we can find m value also. Then how to find that m value is, if you cross multiply that 1 minus m is equal to v by f, that is. Then bring this m this side and 1 by v by f this side. 1 minus v by f is equal to m, that is. Therefore, m is equal to, if you take LCM f, then f minus v by f. This gives you m value, that is in terms of focal length and the image distance you are taking. Then whereas in case of, if you want to take in case of focal length and object distance, if you want to take, where f is equal to, we got u by 1 minus 1 by m, that is. Then what we need is, we need m value here. Then if again if you cross multiply that, f of 1 minus 1 by m is equal to u, that is, if you take LCM here, f of m minus 1 by m is equal to u. Then if you multiply that, f into m minus f is equal to mu, that is, bring that mu this side and f that side, then f of m minus mu is equal to f, that is. Then if you take m common now, then f minus u is equal to f, then finally m is equal to f by f minus u, that is. So, means we can have the magnification formula by using f minus v by f or f by f minus u, or m is equal to, we already know that, minus v by u, that is. Okay. So, depending on the given problem, we can adjust our magnification formula. Okay, depending on +1, depending on the -1 also we can take. Again, we are having a different question is given that if x, y, z and t, where x is about the object distance, y is about the image distance, z is about the focal length here, where t is the radius of curvature, what we have to find is find the correct relation in the between these 4 parameters, that is. Okay. So, of the given options we are having a is equal to z is equal to x plus y by xy, xy by x minus y, and z is equal to xy by y plus x, and x is equal to zy by x plus y, that is. Okay. So, zy by x plus y, that is. Of the given options, we have to find which one is the correct relation here. Then actually in the given options, if you convert that into our convenient language, of which object distance actually we represent with u, image distance is with v, focal length it is of f, radius of curvature is r, that is. Then the first equation it tells about z is equal to x plus y by x minus y, where z is equal to, here it is f is equal to x plus y, which is u plus v by x y, which is u v, that is. Okay. Then actually our relation to the focal length, it is of equal to z is equal to, that is, f is equal to 1 by f is equal to 1 by v plus 1 by u, that is. Then if you cross multiply that, then 1 by f is equal to v into u, u v is the LCM, then we will get v plus u here. Then in terms of this, if you want to write here f value is equal to, from this it is equal to u v by v plus u, that is. This is the actual relation we have. But here given that according to the first one is like u plus v by u v, whereas second case b, if you take f is equal to xy means u v by x minus y, which is u minus v, that is, whereas z is the C option we have, that is of z is equal to xy by, which is z is equal to, means f is equal to x into y, which is u v by v plus u, that is. And D option, that is like x is equal to, where x means that is object distance, u is equal to zy means which is f into y, it is nothing but v, f v by v plus u, that is, or u plus v, that is. So, these are our given options here, but when related here, the actual relation is f is equal to u v by v plus u, that is. Okay, u v by u plus v, that is related same like u into v by v plus u, where u is nothing but, here u is nothing but the x, okay, and v is nothing but the y by v plus u, where v it is of y plus x is equal to z. Then which one it matches is same like zy by y plus x, that is, which is option C is correct, like this. Okay. We can find the different relations, that is. The same question they may ask like this also. Again from the previous question, again we have to find the correct relation between them. This time we are having t also involved here, where t is nothing but the radius of curvature. We know that the focal length to the radius of curvature, the relation is r is equal to 2f, r is equal to 2f, that is. If we change our equations according to our usual parameters there, for example, A you are taking, option A becomes t is nothing but the radius of curvature. So, r is equal to, that is, xy, where x is nothing but the object distance, y is nothing but the image distance, by 2 of which is u minus v, that is. This is first case, and second option, that is like x minus y, which means x minus y, u minus v is equal to 2 into t means r, that is, by xy, where x is again object distance, y means again image distance, that is, which is xy means u into v, that is. And option C, x plus y, which is u plus v is equal to u into v by 2 into r, that is 2r, that is. Then and option D becomes x plus y, which is u plus v is equal to 2 times x y, which is u v by u plus v, that is of r, that is. Okay. Like this we have the options are given there. Actually, relation we already know that is of as 1 by f is equal to 1 by v plus 1 by u, of which it is of Vu is the LCM and we got u plus v here, that is of 1 by f, that f is equal to here it becomes Vu by u plus v. And this is in terms of focal length we have that relation, but there given it is of radius of curvature is there. As it is of radius of curvature there, then we know that as r is equal to 2f, then f becomes r by 2, that is. F becomes r by 2 means if you substitute that value here r by 2, f is equal to r by 2, then r by 2 is equal to Vu by u plus v, that is. Okay. Then from this you can write r by 2 is equal to Vu by u plus v. If you check the relation here we are having u plus v is there. So, means not the option A here, option A is wrong. Whereas, in case of B, there also we are having u minus v is there. So, that is why not the option B. So, only in between C and D only we are having our correct relation there. And here it is given that u plus v is equal to u v by 2r, that is. But here if you cross multiply that, we are getting 2 into Vu there and r into u plus v there. So, that is why not the option C also. And u plus v is equal to 2 u v by r, we can get that one, because here if you bring that r this side, then it becomes r, and bring this to this side, r by 2 is equal to u v by, bring this u plus v this side, then it becomes r by 2 is equal to u v by u plus v, that is, of which our given option is also same. Okay. So, that is why the answer here in this case is equal to D, that is u plus v is equal to 2 u v by r, that is. A dentist has a mirror of focal length 18 mm and he views the cavity by holding the mirror at 9 mm from the cavity. Then the magnification of the cavity is you have to find here. Actually, if you observe here, a dentist is given using a mirror. Actually, dentist uses a concave mirror to get a enlarged image, that is. So, which is our problem, it is about first conclusion, that is about concave mirror, that is. We are going to use a concave mirror, that is. Now, when this concave mirror which is having a focal length of 18 mm is given, the focal length is given as 18 millimeters, that is. And he views the cavity by holding the mirror at 9 mm, that is. So, means he is placing the mirror near to the cavity, so that the distance is of 9 mm, that is, which means nothing but the distance between the object and the mirror, that is. As it is the distance between object and the mirror, that is going to be our object distance, that is, which is 9 mm, that is. Then from this cavity, then the magnification of the cavity we have to find, which is m value we have to find. Okay. Then we know that as 1 by f is equal to 1 by v plus 1 by u, that is, then 1 by focal length is given as 18 mm and 1 by v value image we do not know, and object distance that is given, that is holding the mirror at a position 9 mm, that is. So, 1 by 9, that is. Okay. Now, in this case if you apply the sign convention here, in case of this sign convention, the focal length of a concave mirror, that is a -1, and the focal length of the object distance, that is also a -1 we have. Then minus 1 by 18 is equal to 1 by v minus 1 by 9, that is. Then if you bring that minus 1 this side, then 1 by v becomes minus 1 by 18 plus 1 by 9 we have. If you take LCM here 18, then you will get minus 1 plus 2, that is, which is plus 1 by 18. This is 1 by v value. Then as 1 by v we got minus 1 by 18, then v becomes plus 18 centimeters, that is. Here you have to observe that plus 18, and that plus represents, that is nothing but about a virtual image, that is. And not only that, the object distance we got 18 centimeters, which is behind the mirror we are getting the image at 18 centimeters. And not only that, what we need is a magnification here. And to get that magnification, we know that m is equal to minus v by u, that is of minus of image distance, that is of plus 18, and object distance that we have minus 9 meters, that is 9 mm, that is that minus minus get cancelled and we are having 9 ones and 9 twos get cancelled. Here we are getting plus 2. Remember, if we are getting m value as plus 2 means this plus represents that is of a virtual image and 2 represents that is more than the size, plus 2 represents more than 1, that is, that is why it is magnified, that is. Okay. So, finally, by using this mirror we are getting the virtual and a magnified image we are getting. Like this we can solve by using this mirror formula. But remember, we have to use the sign plus or minus. Here in this case it is plus, because this is the object is placed in between pole and the focus, because focal length distance is 18 mm, but object is placed at 9, which means that object is placed in between the pole and principal focus, that is. So, that is why here we are getting a magnified image, which is the special case of our concave mirror, that is. In order to produce an image with a magnification m, a concave mirror of focal length f is used. So, which means the magnification is already given, and a concave mirror of focal length f is used if the object is kept at d from the mirror. So, object distance given, image distance is image distance not given, focal length is there and magnification also given there. Then what we have to find is here m minus 1 of f, it is equal to how much value we have to find here. Then as the given one, it is of a concave mirror is given, as it is of a concave mirror and with magnification m and the focal length is f. These are the given values, and we know that as the magnification m is equal to v by u, that is, then given that object distance is given there, where object distance is equal to d is given, object is kept at a distance d, that is. So, that is why here this object distance is d, that is. Then from this we can write v is equal to m into d, that is, means the image distance becomes m into d. Then actual relation for this mirror is 1 by f is equal to 1 by v plus 1 by u, that is. Then as 1 by f is equal to 1 by v plus 1 by u, if you substitute the values here, we got 1 by f is equal to v value, it is m into d, plus 1 by u value is given, that is called d, that is. Then if you apply the sign convention, as this is of a concave mirror is given, then here we are having object distance, we have to take that as minus, that is, then 1 by f is equal to 1 by m d minus 1 by d, that is. Okay. Then if you take LCM here, then 1 by f is equal to 1 by m d, then 1 minus m we will get. Then if you cross multiply that, then you will get m d is equal to 1 minus m of f, that is. Okay. Then if you apply the sign convention here, as focal length it is of a negative we have, that is why here if you apply the sign convention for the focal length, then minus of minus here, then m d is equal to, it becomes m minus 1 of f, that is. So, means m minus 1 into f, it is equal to the distance m into d, which is nothing but our image distance, that is. Okay, which is nothing but our image distance, that is. Now, the next question is, if the focal length of a concave mirror is f, an object is placed at a distance p from the principal focus, then magnification is given by. So, which means as it is about a concave mirror again, if you are taking a concave mirror, here it is given that an object is placed, so that this object is placed from the focus at a distance p, that is. It is placed at a distance p from the focus, that is. And actually the distance between focus to the pole, which is the center of the mirror, we know that that is nothing but called the focal length, that is. Then the object distance become finally u is equal to this f plus p, that is. So, u is equal to f plus p, that is. As u is equal to f plus p, that is, then focal length is given as f. First we have to find v value, that is. Then we know that as 1 by f is equal to 1 by v plus 1 by u, that is, then 1 by f is given as f and v value we do not know, but the object distance it is 1 by f plus p, that is. Okay. Then if you substitute the sign convention here, in case of object, that is minus you have, and in case of focal length as it is concave, for that also we are having minus is there, and finally it becomes minus 1 by f is equal to 1 by v minus 1 by f plus p, that is. Okay. Then we need 1 by v value, then bring that 1 by f plus p to the other side, then 1 by v is equal to, then 1 by f plus p coming this side becomes a plus minus 1 by f is there. Then if you take LCM there, then you will get f of, if you are taking f is equal to here LCM here, then you will get f of f plus p, that is if you take LCM f minus f plus p, that is into 1 by v, that is. Then if you simplify that, then 1 by v is equal to f minus f minus p by f of f plus p we got. Then f get cancelled, and finally 1 by v value we got minus p by f of f plus p, that is. So, as we got here 1 by v is equal to minus p by f of f plus p, that is. Then magnification we know m is equal to minus v by u, that is. Then minus v by u means minus of, here v value we got, from this we can write v is equal to minus of f plus p by p, that is. Then magnification m, which is minus v by u, is equal to minus of v value we got minus f plus p by p by, and object distance which is of we got f plus p is there. For object distance also we are having minus is present, and this minus get cancelled, and f plus p also get cancelled. Then m is equal to, the magnification becomes, then m is equal to minus of f by p we are getting. This minus actually it represents about, that is an inverted image is formed, and we got the ratio f by p, that is.